Hello and welcome to another Solana tutorial. This is a bonus video. When I made the video on Blinks, I did kind of a detour on transaction signing and how transactions are built on different clusters. Spoiler alert, the same. And that has security implications. And I had a hands-on example on why that is a problem and what you need to be careful of as a dev and as a user of Solana. This has been recorded in the middle of making another video, so you might be missing the context of where we are. So if you haven't seen it, do check out that video on Blinks. First link in the description or up here if you want more of a context, but you should understand most of it if you just watch this short little video. Phantom is still set to mainnet now, so it forwards this transaction signed to mainnet. Mainnet is like, I'm not going to do anything with that. That's not a valid block hash. So mainnet declines it. However, if I were to put that signature into the same transaction that I serialized here, then I could send that transaction. Because DevNet and mainnet have the exact same way how they produce signatures. Nothing in the message is different depending on which cluster we're on. That's why in the very beginning we also saw this message, warning, this transaction is valid on mainnet. I can show you this, hold on. If I give you a block hash from mainnet, then you will get failed to fetch because 0. Why does it fail to fetch actually here? No instructions. We only do that if we have instructions. Then we get around this error. Just as a quick fix. Why do you fail to fetch? Not the right thing. Better? Ah, that's better. Okay. So apparently an empty array is sum, even if the length is 0. Fine, sure, whatever. TypeScript, whatever. Point is, here, now it says, oh, this is, yeah, it looks like it's not doing anything, but it is a valid transaction for mainnet, right? So here it lets me sign that properly. However, let's cancel. If I set my wallet to DevNet and I produce such a transaction, then the wallet itself warns me, hey, we are on DevNet, or at least you set me to DevNet, but you're trying to sign something that is valid on mainnet. Are you freaking sure? Because this can be an attack, right? You think, oh, I'm just signing stuff on DevNet, but really it produces a valid transaction on mainnet. So Phantom gives you this warning and blocks the request. You can go around that and be like, yeah, I know what I'm doing. But you need to twice click a red button. So let's cancel that. And that's exactly what's happening, but in the other way around. In that we are set to mainnet with a wallet, but we sign a transaction that is valid for DevNet. And here, Phantom doesn't do that check. Hey, this is a DevNet transaction. Are you sure you want to sign it on mainnet? No, it just says, well, this transaction won't go through. I will, if you click that button, send it to mainnet for you in any case. But just note that this is not gonna work. And it's right. If we do that, this is not gonna work. If you send that transaction to mainnet, obviously it's not gonna land there, right? On mainnet, because it never was a valid transaction on mainnet, and even on DevNet it's not a valid transaction. Why? Because we didn't send it to DevNet, because the wallet was set to mainnet and also this page was set to mainnet. However, the very funny thing here is if I do set my wallet to DevNet and I give it a DevNet transaction to sign, but the page tells the wallet we are on mainnet, then the wallet is very confused and says, I'm simulating on mainnet for you, here you go. This will not work. But if I confirm this, it produces the signature that is also valid for DevNet. And since we're set to DevNet, it also sends it to DevNet. And that's why this thing will now land on DevNet, right? Yeah. This is so stupid. But yeah, I mean, things you find out when testing. This is how wallets behave. Weird. Phantom behaves really weirdly. I mean, like in this case, Phantom, you should either simulate for DevNet and send to DevNet, or keep simulating for mainnet and also, I don't know. I don't even know what I want you to do in this case, but it's really weird behavior. I mean, I said we're gonna publish the Blink, but I'm getting too excited about this now because I wanna teach you more things. Like, see, this is the fun part. This is where it gets fun. Now I can teach you interesting things about Solana again. we're gonna do a detour into Solana transactions and signing because I just find that more important right now. And we postpone that other topic of publishing the Blink because this is cool. Let me first grab a drink and then we have a look at this. Because, so here's my challenge for you. Let's say we are operating on mainnet with my wallet. What do I need to do in order to still get that transaction to DevNet if the wallet does not send it to DevNet because the wallet is set to mainnet? And that's a form of hacking that teaches us something, because it's the exact same that hackers can use just the other way around to trick you into signing something on DevNet and then send it to mainnet. But for our tests, we sign it on mainnet. Well, actually, no, we signed DevNet, but the wallet is mainnet. And we want to still send it to DevNet. Think about what information does the attacker need to get in order to be able to send that transaction. And if you don't fully understood that, this is security stuff. That's why I'm getting excited about that, because I want people to be aware of this stuff. Let's say we as the attacker build this Blink. We know what it does. We know how the transaction is built. We send the transaction to the wallet. However, the wallet is set to a different cluster, in this case mainnet. And if I sign with this, it will not land on DevNet because Phantom is not sending it to DevNet. But how can I still get that transaction to DevNet? What do I need to know and what do I need to do? Think about it while I grab a drink. Okay, what's the answer? What does the attacker need to know? Or what do we need to know in order to send that transaction? Tell me. 2 things. What are they? It's pretty simple. The transaction. Yes, that's correct. More specifically, the message part of that transaction. You can just think of what that transaction is made of. The message part and the signatures. So what do we need? Well, the message and the signatures. In this case, we have one signature. And with the message, we can build a transaction, like a properly valid transaction. If we have the signature that is valid for the message, then we have a valid transaction. And basically here we have all the parts to do this. So let's do a quick, just as an exercise, a quick little manual sending. I'm just gonna put a new file here, it doesn't matter. Manual sends. An async function taking absolutely nothing and doing absolutely everything. We need a connection to, like we do here, to DevNet. And then we need to build the transaction. And here I ask myself the question, what do I build the transaction from? What do I have? Well, I could either run the exact same thing as I have here, you know, with setting the fee pair, getting the user, just putting in the user pub key. That's one way. But important is also that I get the exact same block hash. And that, if I run it in not the exact same second, will be difficult. So I'm gonna do the opposite of that, where I deserialize a given string. So also a transaction from a buffer, pass a wire transaction. So basically we just need the buffer and that. So we need the serialized transaction somehow, and we decode that base 64. Then we have the buffer, so that's decoding and then deserialization into that transaction object from the decoded buffer. Then we should have the transaction. Fee pair and block hash and everything should be set. The only thing that we need to change in that transaction is the signatures. Is there a set signature? No, I don't want to sign, I just want to add the signature. So signatures, the first one, the pub key should be set, but the signature, can I set that to whatever? Or is that read only? Buffer from, and then we play the same game. Oh, except this time it's a base 58 encoded signature. So the signature will be base 58 and this one will be base 64. So here we will need a BS 58 decode. Do I have that? I have that. Wonderful. Decode signature. And this is read only probably. Oh, hold on. No, wait. This gives me a uint8 array. And then I just say from a uint8 array that should work, I think. Cool. And I can just set the signature. That is not just read only. Wonderful. And then I can just send that transaction. This, by the way, is deprecated. You should not use this anymore. Fine, I sent raw transaction just so I get around the deprecation warning. And I do the same thing with serialize this transaction. And this part here, this will actually check my signatures. I can also say I require all signatures and I want you to verify my signatures, which it does automatically on default anyway. But just to make it explicit, here I want those two things, because if that's not given, like if the signature doesn't actually correspond to that transaction I'm getting here, or if I need more signatures or whatever, or if it doesn't verify, right, then this is not going to work anyway, and that will already fail and give us that warning, right? If I choose a random signature and a random transaction, this won't match, and therefore if I run this, with those two that do not match, we get invalid signature for pubkey, this hot wallet, because the signature, if we put it in here in that transaction, you know, all those zeros that are represented by A's, that's where the signature should go. And that's probably decoded this pubkey, and then that's the instruction stuff and the block hash. But in order to now get this to work, we need the right values. So what were we doing? We create that transaction and we confirm it. And you know, just to double check, this is not working, right? It does not go on DevNet. This is not being sent to DevNet. Phantom is trying to send this to mainnet. But I can take this signature, put it here, and I need to find the transaction that it's signed for. So this is the request where when I click that button for that public key, produced this transaction. So if I copy all of this and I put it in here, then that should produce a valid transaction. If I now execute this, nice, this is a valid signature for this transaction. Otherwise we would have failed here, but we cannot send it because the block hash is not found. Why? Because I was talking too long and I was taking my time. I need to be very quick with this for this to work, because block hashes are only valid for like a minute or so. But if I'm quick with this, I can send that transaction. So let's do it. Full speed. Okay, I gotta copy two things. I gotta copy the transaction and the signature. Let's go. So click this and confirm. Here was the action. That is that transaction. Copy all of this because this has the most recent block hash. And then that transaction that we're trying to confirm here. Whoops. Here, that's the signature, and if I put that together and manual send it, just worked. It just sent it. I'm not waiting for any confirmation or anything, but this thing should now maybe even, oh no, it's querying on mainnet, so no, it doesn't. But on DevNet, I should now get this transaction. There you go. I just sent this manually because Phantom was trying to send it to mainnet, but I sent it to DevNet. What am I doing? Nothing, because it's literally an empty transaction. But hey, I could send it. I could send that empty transaction. And if I had a token account here, right, and I would do the same thing, right? So this has one empty token account now. If I confirm this, it's still not getting sent. This transaction is still not landing on DevNet, not here. But if I'm fast enough and I put the signature in here and I put the correct transaction, oh, come on, be fast. Boom. And quickly in the right tab, execute that. Then, too late. Wait, no. Invalid signature. You sure? Wait, what was that transaction? Closing one token account. Should have been that. Why is that an invalid signature now? Did I not copy that right? Interesting. Why do I now get a signature verification fail? Let's try it one more time. Is that a valid signature? No, this time it's not. Oh, I know. For some weird reason, now that it's not an empty transaction, Phantom does more things, right? That's why it's not working anymore. Again, Solana basics. Phantom is sneaky and changes the instructions in that it adds compute budget instructions, which actually, fair enough, if we were to build a proper Blink, we probably want to have them in our Blink anyway. So that just reminds me that I should probably be doing this for times of congested mainnet, or like always, compute budget is probably a good thing to do. So yeah, let's do that. In the process of playing around, we are improving our script. So we add a compute budget program, set compute limit. I don't know how many we need. We would need to simulate that and then check, but I guess 100K should be enough. And then we also add a set price. I don't know what's a good price. I don't know. It doesn't really matter. Let's do 10K microlamperts per compute. And if I have those added, then Phantom will be like, okay, they're already here. The user wants this specifically, so we're not gonna change it. And that way the signature should then also be valid. So let's check that. I click the cleanup. I confirm this. This was the action. I'm gonna borrow this transaction real quick to my manual send. Yeah, I really just have 1 minute for getting this done, so I'm gonna be quick. And then also I would like to have the valid signature that I put here now, and that way hopefully the manual send will actually work. Yes, it does. And having this valid signature, I now sent it on DevNet, even though Phantom was totally set to mainnet. Phantom and this page are set to mainnet, and I manually send it to DevNet with the compute budget instructions like this and the one close account. That's how you can do it. So what did we learn from all of this? Well, first of all, transactions are built the same way on DevNet and testnet and mainnet. So it doesn't make a difference what cluster the wallet is set to. The transaction signature can be used for all of the clusters, provided that it's valid. And usually it's not valid because of the block hash, because the block hashes are different on all of the clusters. That's why you also need to be careful for other like Solana copies or whatever. Somebody could spin up a cluster of Solana and use the exact same block hashes. I mean, they would need to, change other things, or they wouldn't even need to. They would just need to ignore the validation of block hashes, and then they can pass in a mainnet block hash, and your transaction will still work on their cluster, but they could also execute the same thing on mainnet, which can do something completely different as well. So be careful. And best practice, use different wallets for different clusters. Like have a wallet that you just use for DevNet and never interact on mainnet with it. Other way around, a wallet that you use on mainnet, don't do anything on other clusters with it. That's just good practice. I'm not particularly sticking to that, let's be honest. But also, it's not like I have that much to lose in those hot wallets that I'm using here. So it would be fine if I lost that, right? That's one thing we learned. What else did we learn? How to manually build those transactions that you don't need much, just that transaction message, this part, and the signature. And then we put the signature in here and boom, we can send it. And all of that started because Phantom is behaving weirdly here on this site, because I guess the site is set to mainnet. It tries to confirm transactions on mainnet. Okay, what else? Oh yeah, and knowing this, that I can do this, manually send that transaction if I have those two things. That's why it's important that the wallet sends the transaction themselves. That's why the wallets are so keen on sending the transactions themselves, so they don't need to expose the signature essentially. They don't need to give you the signature that the dApp can do stuff with it, but they send it to the RPC directly. I here have access to this signature because I'm in my local browser, right? And I can observe what Phantom is sending out, or what this page is querying, what signature is trying to get. Because Phantom was like, oh, I sent the transaction anyway. I made sure that that gets to the right cluster, but the cluster doesn't accept it. But then it still provided the signature, and the dApp itself could now do something with that signature. It tries to confirm that signature, get the signature status. And that's where I, as the dev here interacting, or as somebody sitting on the wire and, observing network traffic, I could now look at this and be like, oh, look, that's the signature. So that's why you want to make sure that your traffic is encrypted, that it's not so easy for an attacker to just read this. Or that's why you want to use a virtual private network, a VPN. And also, that's why you want to keep people away from accessing your local machine. That would be even worse. If they have access to my browser directly or, my machine, that's really bad for my security because they can, look at all that stuff. Yeah, I just want to make you aware of security concerns. My favorite topic. But okay, I think we did enough of a detour into Solana security. Yeah, and that's that little detour. I hope that you enjoyed it. It's just always so fun to me to explore Solana like live, whenever stuff comes up. Yeah, this is happening, yeah. And I hope that you learned some stuff. Like that transactions are built the same on all of the clusters. You might have already known that, but it's always good to bring it back to memory just so we're all aware that, yeah, attacks can happen that exploit that. And that's why wallets are careful. Phantom is being careful. Still behaves weirdly if you ask me, but they are being careful. All of that said, let's go back to building that blink. The video is here. And if you're not interested in blinks, here's another video that YouTube recommends to you. Make sure you like this one. I'll see you in my next detour or wherever. Yeah, Solana is fun.